So welcome everyone who's joined so far. I'm Steve Young. I'm a retired longtime EPA employee, kind of specialized in environmental information during my years at EPA. And I am the current co-chair of the ESIP Air Quality Cluster. So we're sponsoring this session. And my fellow co-chair, Beth Huffer, I don't think Beth is going to be able to join us today due to a conflict. Though I also want to acknowledge Sahara Ali is with us. And Sahara last year was the ESIP fellow who supported our work and was great. And she's graciously joining us and helping for this session. So I just want to acknowledge all of the help that we got from Sahara, which was great. And once again, people, please take a look at the link in the chat. And if you haven't signed in on our Google Doc, please sign in, and we will be coming back to that document later. So I'm going to go ahead and start my opening presentation. If you'll bear with me for a moment. Let's see if I can do this once again. All right, I told it to start from the open. Here we go. Okay. So you heard a tiny bit about me. Let's just open with the notion that air quality is an enormous issue. It has health ramifications. It has ramifications on our natural and agro ecosystems, the economy and well-being, very complicated interactions with climate in general. And we've learned increasingly in recent years that vulnerable communities are disproportionately impacted by poor air quality. And it's going to make me, there we go, it doesn't want to advance. For health alone, recent estimates are that millions of excess deaths annually are caused by poor air quality, and various numbers have floated around, but 7 million to 10 million per year is a range that I've seen a lot recently. And the range of health effects is staggering. And this is just some of them. This isn't even everything, but almost any kind of adverse health condition that you can imagine has been associated with poor air quality. So it's really a huge, huge problem for human health alone. Ecosystems are also affected, and people may not be as conscious of the ecosystem impacts, but we're still seeing adverse impacts on ecosystems. The worst days of acid rain may have passed thanks to successful control measures, but we're still seeing acidification of water bodies. We're seeing nutrient enrichment, eutrophication, problems with toxics like mercury that enter into the system and contaminate fish, etc. And ozone is very destructive to vegetation, among its other adverse impacts. The societal cost of health impacts range well into hundreds of billions of dollars. The crop losses are into the billions. There's also damage to materials. Rubber and ozone don't get along very well. Buildings are degraded, building materials. And also from a quality of life standpoint, visibility, smoke and haze impair visibility, and that's been a long-standing issue, for example, in the Western United States. This is also, it's just complicated. There are many domains all interacting with each other. There's the physical chemical domain, the health domain, the ecological domain, et cetera, et cetera. And last but not least, the technology and the legal administrative framework that's in place to attempt to address air quality problems. So our thesis for this session is that open, real, and actionable information is fundamental to drive improvements in air quality. And I'll show you in a second kind of a simplistic logic chain, but there's this notion of providing information, everyone's right to know, environmental right to know, the right to understand, not just knowing, but to actually understand what does it mean, and the right and the capacity to act, empowerment, using information to empower people. So this is sort of a simplistic logic chain that we might come back to during our discussions, but perhaps we start with data, but as we go down towards the lower right, deriving information from data, knowledge, the understanding, driving hopefully good decisions that lead to actions, and we hope ultimately positive outcomes. We need real data, and when I say real, I mean everyone knows real time. We're familiar with talking about real time. Real place means, okay, the place that I'm concerned with, like maybe where I'm sitting indoors right now, what's the air quality right where I am in the real place, or the place of interest, not just sort of somewhere within 100 miles of here, this is the air quality. And finally, real composition, what's actually in that air, both the components, the speciation, and the levels, the concentration. We have some exciting new opportunities. We're going to be talking about some of that today. A lot of amazing new sensing capabilities, modeling advances, including improved forecasting, which is clearly really important, tremendous advances in general in computing and networking, and also the emergence of, pick your preferred term, participatory community citizen science, getting people involved in collecting information. So we have this idea that we'd like to rough out the scaffolding for a community air quality toolkit. And this is a question we'll be exploring in this session. What information resources can we provide to help more communities enhance their air quality programs? Maybe they're just starting up a new program. We're seeing a lot of that. Maybe they're trying to improve an existing program in the community. So our session plan for today, we're going to have a speaker panel, and I'll begin introducing them momentarily. We'll have some discussion and Q&As with our panel. And then we're going to take a little break and kind of shift gears into information harvesting, trying to gather information resources that we think would be helpful for communities, and some kind of closing discussion, time permitting, about the community air quality toolkit concept. So again, for those who've joined us since I started talking, if you haven't signed in, please go to the link in chat and sign in there on the document. And thank you for doing that. And I'll just close with, in the document, we'll come to this later, but we've kind of collected some questions that we think communities are asking, or could be asking, might be asking. So we want to make sure that we've identified, as many helpful questions as we can as part of this process. So, and again, the shared document that I've been talking about. And also, if you're not comfortable, I know that not everyone is crazy about interactively contributing to a Google document. You can always, or maybe something occurs to you later, please feel welcome to email thoughts that you may have to me at frasmo@gmail.com. So with that, I am going to stop sharing and introduce our first speaker. David Moroney is with NASA JPL, and he's an applied science systems engineer working on a plethora of projects and tasks in the realm of cross-disciplinary earth science data, informatics, and open science platforms. And one of his tasks is to support the Maya mission's early adopters of pre-launch simulated data on behalf of NASA's Applied Sciences program. So David, if you can, put it on slideshow mode and take it away. Thank you.
All right, thank you for that really kind introduction, Steve, and thank you for having me. Hopefully you can see my slide okay, my intro slide, and you can hear me okay. I just want to start off by acknowledging Abby Nastan, who is the Deputy Program Applications Lead, also known as the DPA, who's assigned to this Early Adopters Program portion of Maya. And I work alongside Abby, so that really makes this presentation possible and kind of like this entryway into introducing Maya to the ESIP community. And I also want to acknowledge Program Manager John Haynes, who's the Program Manager for the Air Quality Program within NASA.
Hey David,
yes.
Can you put it on slideshow mode? We're seeing the, the non-presentation.
Oh, let me see if I can swap that out. Give me one moment.
Thanks.
How is that?
We're still not seeing, the actual presentation mode. We could see it, but it's showing all of the slides and the notes panel and everything. Let me
go back and
you see
it.
up top the slideshow thing. Yeah, right by there. Try play from start all the way to the left. Try that. Once in a while, we've seen these funny glitches.
How is that looking?
No, try it again.
I'm gonna try swap displays and see if that helps.
Sure.
Did that fix it?
No change so far.
You may want to try just stop sharing and try again and see if you can pick but
I'm gonna try and maybe I could just share my entire screen. Maybe that'll fix the problem. How's that?
Perfect. Good.
Cool. I apologize for that little glitch there. Anyways, as I was saying, John Haynes, I just want to acknowledge John Haynes for providing the funding for this project under the Applied Sciences Program for air quality. All right, so Maya is fundamentally motivated by the need to explore the linkages between exposure to different types of particulate matter, what I'll hereafter refer to as PM, and also associations with human health. There's a variety of public statements that we see here on this slide captured from peer-reviewed research, all of which collectively articulate the issues of PM toxicity, human health risk to PM, and the lack of observations available to reliably identify the effects of PM based on different chemical components of PM. What is perhaps the most motivating statistic here is the 90% number that you see here of the world's population lives in areas exceeding the World Health Organization's air quality guidelines. Maya is commissioned here to help address these observational data gaps by providing 24-hour average concentrations over prescribed target areas of PM10, PM2.5, and speciated PM2.5. When we say speciated PM2.5, what we're referring to here are the observables such as sulfate, nitrate, dust, organic carbon, and elemental carbon. And PM10, in case you are unfamiliar with that, is referring to particulate matter at discrete particle sizes up to 10 microns in diameter. And the PM2.5 is for particle sizes up to 2.5 microns in diameter. So the data from Maya can then be fed into epidemiological studies and help provide improved statistical correlations to birth data and hospitalization data. Maya, which stands for the Multi-Angle Imager for Aerosols, just became officially recognized as a joint collaborative mission between NASA and the Italian Space Agency, which secures the pairing of the Maya instrument to a launch vehicle and spacecraft that will be provided by ASI with the revised launch estimate to be later confirmed, but probably sometime within the year of 2024. So the graphics here provide a visual of how the assembled camera viewed on the bottom left fits within the satellite instrument package in the middle diagram. The photo in the top right that you see here represents the fully assembled satellite instrument package. Maya's core science objective is to study the effects of various types of PM on acute illness and premature death, adverse birth outcomes, and chronic disease through epidemiological studies. Unique to the Maya mission, contrasted with other major NASA Earth science missions, is the primary focus on human health, societal benefit, and the inclusion of epidemiologists on the Maya science team and the group of Maya's early adopters. Maya contains a spectropolarimetric camera that is pointable in the along track and cross track directions over prescribed target areas, what we also refer to as primary target areas, or PTAs, also secondary target areas, also known as STAs, both of which we'll briefly go over in an upcoming slide. Having a dual axis gimbal on the camera gives Maya the ability to provide a long track multi-angle views and a wide cross track field of regard. The mapping animation that you see here on the right gives a sense of the 2D mapping pattern. We also note here that Maya operates in a multi-spectral wavelengths, including ultraviolet, visible, and near infrared, and shortwave infrared. The VNIR band is the most sensitive to fine aerosols, such as PM2.5, whereas the SWIR is more sensitive to coarse aerosols, such as PM10, while UV is sensitive to both fine and coarse aerosol absorption. Maya also operates in two distinct viewing modes. The step and stair sequence provides discrete viewing angles for more detailed image capture over the same geographical area. The sweep mode of operation utilizes the gimbal itself of the camera to move continuously over its prescribed range of motion, thereby enabling its wide cross-track field of regard. So what we see here is just the overall list of the Maya's applications and kind of the end user types that we have so far identified. We say that this is a non-exhaustive list because we see that as we continuously engage users and early adopters, this list is somewhat can kind of be expected to grow, if you will. So the data itself could be used for anything, as I mentioned, epidemiological studies, anything related to that, human health, health impacts, air quality management in general. The EJ stands for environmental justice. So there's some environmental justice groups that have been engaged in their initiatives are along with that. A variety of culture, heritage, and environmental health aspects in aerosol / cloud research. We've identified here this list of Maya users so far that we've engaged. Epidemiologists has already been mentioned, but along that line, we have health researchers and hospitals and so forth that are part of that. We have air quality managers, both US-based and international, and we already talked about the environmental justice advocates that are part of this. Academic researchers across all of academia that are involved with these types of studies, consultations with air quality and consultants and modelers. So modeling also is a big part of this. And museum researchers, air quality monitor manufacturers, including for the ground-based surface network of air quality sensors, and also a variety of students that have been engaged up to this point. So as I mentioned in the opening, Maya has been assigned a Deputy Program Applications Lead, also known as a DPA, which has been sponsored directly by the NASA Applied Sciences Air Quality Program Office. So John Haynes, as I mentioned, is the program manager for that, and Abby Nastan is the DPA assigned. And so a big part of my work with the DPA is ensuring that Maya is partnered with the right set of early adopters, which are essentially a target set of user communities. We saw an example of that in the previous slide. For the Maya data, as well as information and knowledge that will become extracted out of the Maya data. So since the early adopters program started in 2019, Maya's base of potential users has continuously increased to an approximate subtotal of just over 200 unique users. And so with each year, the user base increases as we provide opportunities for engagement, such as workshops and sessions at various conferences, such as AGU and AMS are kind of the big legacy ones. But as of today, this now, I'm happy to say, includes ESIP. So as the pie chart indicates, the base of potential users extends from various nonprofits to epidemiologists to various atmospheric research across academia and governmental agencies to environmental justice advocates, as we mentioned earlier, and all the way to the air quality managers themselves. In the pre-launch phase, Maya science team members have been working to produce simulated data products to familiarize the team members and early adopters with the format and structure of Maya data and measurement variables before it becomes operational in the pre-launch phase. So we have a version 1 level 2 PM product that's already been made available through this thing called NASA Box for evaluation. A level 4 PM product has also been produced by one of Maya's science team principal investigators named Yang Liu, who's in partnership with the New York City Health Department. So these data will become publicly available later in this year with the NASA Earth Data Search System by way of the ASDC DAC. So I'm collaborating offline with Beth Huffer on that activity as well. So anyone who would like early access to these data may fill out a request form via the link that you see here at the bottom of the slide. All right, so this list that we see here represents the current set of primary and secondary target areas, or PTAs and STAs respectively. The PTAs are used to ensure Maya is able to meet the baseline science mission objectives with approximate coverage of 3.5 or so overpasses per week, whereas the STAs are considered more best effort with a nominal overpass frequency of about 2 per week. So not on this list are the calibration target areas. So just because we're focusing for this target audience on the STAs and PTAs. But for the calibration target areas, this is a separate list of sites primarily used for calibration and validation based on proximity to the surface monitoring network of sensors, the majority of which have already been deployed and are online operating in advance of Maya's launch. So in addition to comparisons with surface monitoring sensors, Maya researchers will be able to combine data from other satellite instruments similar to the type of observations that Maya provides, as well as numerical models to generate PM exposure maps and conduct epidemiological studies. So this map that we see here gives us a geographical representation and distribution of the PTAs and the STAs that we just saw on the previous list in the previous slide. The blue dots indicate where the PTAs are at, and the green dots are the STAs. So from this view, we can see that there is coverage on 6 continents at this point. So thank you for having me. And again, if you would like to become an early adopter, please feel free to sign up, and the link is right there. Thank you very much.
All right, David, thank you very much. And I will say I've been really impressed in recent years by the work that NASA has been doing with upcoming missions like Maya to engage more widely with users or potential users. And I think that's really been great to see. And I know a number of people are very interested in the Tempo mission that's coming up as well. And I believe Tempo is also has really tried hard to engage with the user community. So kudos for that. Okay, we will now move on to our next speaker, Young-Sun Jung from NOAA. She is the Air Quality Program Manager at NOAA's National Weather Service, managing the National Air Quality Forecast capability that provides operational air quality forecast guidance for ozone, PM 2.5, smoke, and dust. Also, she's an expert in storm scale modeling and data assimilation, ensemble forecasting, and microphysics. So, Young-Sun, please share your screen and take it away. Thanks.
Oh, Steve.
Oh, was I going to drive? I'm sorry. I lost track. My bad. Okay, bear with me for a second. I'll just take a moment. I'm glad you reminded me. We're getting there. Now all I have to do is share screen. Getting there, getting there. Okay.
Okay, thank you. Thank ESIP for giving me the opportunity to speak for NOAA today. I am Young-Sun Jung, as Steve mentioned. I'm the Air Quality Program Manager at the NOAA National Weather Service. Today, I'm going to introduce the Air Quality Program at NOAA, the entire NOAA side, and then a little bit more about the National Weather Service side Air Quality Program. This presentation contains contribution from the National Weather Service Environmental Modeling Center, EMC, and NOAA OAR labs, including Chemical Sciences Lab, Air Resources Lab, and Global Systems Lab, and OAR Climate Program Office, and then also NESDIS to cover air quality activities in both research and operations. Next slide, please. NOAA has a numerous mandate to observe and predict atmospheric composition for various hazardous weather conditions that include poor air quality from wildfires, volcanic eruptions, and then anthropogenic emissions. Various mandates include a Clean Air Act and Montreal Protocol for monitoring, assessing, providing measurement of, and reporting on the state of the stratospheric ozone layer. EPA NOAA MOA requires 2 agencies to collaborate in forecasting air quality. NOAA also initiate on-demand air quality modeling per event notification from International Atomic Energy Agency, Comprehensive Test Ban Treaty Organization, Homeland Security, Anchorage VAC, and Washington VAC, and other partner agencies. And to support this air quality forecasting, NOAA Office of Oceanic and Atmospheric Research, called OAR, conduct a wide variety of research on atmospheric composition and air quality. Next slide, please. And this slide shows NOAA's air quality capabilities, aiming to observe, understand, and predict atmospheric chemical composition and air quality. OAR conduct various field campaigns to collect measurement from surface instrument, aircraft, and ships. And NOAA also operate a surface monitoring site and satellite data from NOAA and partner agencies like NASA are being actively used to monitor wildfire emissions and greenhouse gases. And by running atmospheric composition air quality models, NOAA provide operational air quality model forecast to 2 partner agencies and the public. In addition, NWS also dispatch instant meteorologists who are specially trained current NWS weather forecasters to the field in the wildfire locations. Next slide, please. This slide shows the types of research, data, models, and services for graphics shown in the previous slide. I'm not going to go through it to save time, but I understand you all have access to my slides, so feel free to read it later. Next slide, please. And now I'd like to talk a little bit more about the operational air quality forecasting at NOAA, which is the National Air Quality Forecast capability I am managing. In the US, air quality forecasting relies on the strategic partnership between NOAA, EPA, and state and local agencies. And state local agencies provide monitoring data and emissions for their respective area. And EPA collects those monitoring data, maintains national emissions inventory, and develop air quality models such as CMAT. NOAA integrate and develop and evaluate those models and provide operational air quality forecast guidance for ozone, PM2.5, and smoke and dust. For ozone and PM2.5, we provide 72-hour forecast, up to 72-hour forecast. And for smoke and dust, we provide forecast up to 48 hours. And our operational product are disseminated via various formats. And for example, graphical data is available through a public website, and model data can be downloaded through the NWS FTP site. And here, the operational air quality forecast guidance can lead, if you click that, it can lead to the graphical display site for operational air quality forecast product. And our model guidance provided to air quality forecasters at state and local agencies. And using those guidances, they issue operational air quality forecast in the form of air quality index. And EPA interpret and disseminate air quality index forecast through the airnow.gov site. And then also NOAA disseminate air quality alert, not air quality index, but air quality alert through weather.gov website. Next slide, please. And the NOAA air quality model is expecting a major upgrade in July 2023. So this upgrade is significant. This is first ever online coupled weather and chemistry model at NOAA. The chemistry model, it means that chemistry model will be run as a component model, like a physics or surface model or land model in the weather model. So they will run concurrently, and then they will continuously feed back to each other. Instead of 3 separate US domain, CONUS, Alaska, and Hawaii, shown in the blue boxes on the left figure, that 3 domains are current air quality model version 6 domain. But with air quality model 7 upgrade, it will run a single North America domain that covers all 3 the air quality model subdomains, and then it will alleviate any issues from unphysical and artificial lateral boundary that affect the interior of a model domain. And then with this model upgrade, we already see a noticeable improvement in PM2.5 forecast with AQM version 7, while improvement is relatively minor in the ozone forecast. And operational implementation is scheduled for this summer. So please stay tuned. And then in the center, you can see the PM2.5 forecast with new plume rise and gaps aerosol lateral boundary conditions. So you can see Saharan dust can move into the domain from the southern boundary of this domain. So we see we are excited about see this kind of improvement compared to the current the operational model. And that's what I have today. And then thanks for giving me the opportunity to speak today at this meeting. Thank you.
Thank you very much, Young Sun. And we will now move. We've heard from NASA and NOAA, and we are now going to move to Ron Evans from EPA. And Ron has been with the US EPA for over 40 years with experience in several different programs. Over the past 5 years, he's helped to co-lead the EPA air program's work on air quality sensors, and he is now the EPA point of contact for the AirNow fire and smoke map. And Ron, bear with me for a moment and let me switch around here.
Okay, sounds good.
Give me a sec. And closing in. How's that look?
Right.
All right. Good. So take it away, Ron.
Thank you. And I appreciate the opportunity to speak. And a little bit of compare and contrast. I'm going to be talking about very much ground oriented and sensors. The new sensors that are coming out in terms of what I've been working with recently and what EPA is doing in this area. So if I could have the next slide. So what I want to cover here quickly is a little bit of the background on the use of sensors, which is some of the questions we'll address later. Talk a little bit about citizen science, which we call participatory science at EPA is the official title now. And I want to talk a little depth about the Air Now Fire and Smoke Map and showing how technology is really able to bring more information to the public. So if we turn to the next slide, I do want to say to start with, sensors are being widely used, and I'm going to focus particularly on PM 2.5 sensors. My particular aspect is going to focus on the ambient use, though we do see a lot of sensor use growing indoor as well in some of our other programs. Now, what I want to do is start here by framing what we think about sensors. Any device that's going to measure air quality has to meet certain standards. And what I've done here is lay out those couple of pieces. So first off, there's the couple of requirements, the applicable requirements, excuse me, that are laid out for measuring the air pollutants. Then there's some requirements that may be in state regs as well. And then in addition to making sure that the monitors are properly calibrated and things like that, you then have to think about sampling, quality assurance, and things. All these three pieces must come together in terms of being able to measure air quality. Now, what we're seeing in sensor applications is that you don't necessarily get all of these. Take, for example, some of the cheaper PM 2.5 sensors that may be put out by citizens. They may not be following the guidance on how to go ahead and cite them. So while we would say that sensors are not going to be able to be used for regulatory purposes because they don't meet all those criteria, it does not say that sensors can't be utilized for a lot of other purposes. And what we're seeing is that those other purposes are growing. And that's where I'd like to turn next, if we could, Steve. So as I mentioned here, this is titled Citizen Science and Community Monitoring. EPA has now adopted the term participatory science to be broader. As Steve indicated, I've been within EPA working on sensor technologies, sensor applications back, I think we started having our first workshops back in 2012. But what we're seeing is technology and sensors has really expanded very rapidly, and it's being easier for non-technical people like myself, I'm trained as an economist, to go ahead and put sensors out and collect good quality data. And really, as I was indicating a moment ago, the quality of the sensors to collect good information has been dramatically increasing over the last few years. Concurrent with that, we're seeing a lot more use by citizens and community groups as well. And up to the point where in the last 2 years, a couple of laws have been passed that have given EPA the ability to pass on grants for community air monitoring to community groups. And a lot of them are using sensors. And as of last November, we awarded $53 million in grants to 132 different community groups. So there's going to be a lot of this coming just from this set of grants alone. What I'd like to do is move to the next slide. What I want to do now is just give you an example, of what how sensors can be used. And what we started out with as a pilot back in 2020 has really grown into something that is readily utilized. So if we could turn to the next slide. So the fire and smoke map, which you just saw a moment ago, is populated with both regulatory monitors and sensors as it stands right now. And I'll talk a little bit more about the numbers of those. EPA is in partnership with the U.S. Forest Service to develop this product. And I cannot say enough about the close working relationship we've had in terms of working with the Forest Service. What you see here is the goals of the fire and smoke map. And I think what's important here is the theme that you'll hear through each of these. So what we're doing in this first one is we're getting information to the public so they can protect their health. And with the addition of the sensors, we're giving that data to them in near real time. The second point here is that this fire and smoke map was really a proof of concept. Can we actually put low-cost sensors on a map and have them directly comparable to regulatory monitors on an apples-to-apples basis? And this pilot proved that that is possible. And then finally, what we've got here on this last bullet is that by virtue of bringing on these sensors, we're going to bring a lot more information to the public by putting them on the same map. So if I could have the next slide. So a little bit of history and what we've accomplished. So as I said, we put this out as a pilot in 2020, not really knowing how people were going to deal with this. 30 million page views later, it's a success. It's the best way to describe it. We've had an incredible amount of input over the last couple of years in terms of how we can improve it. And we're now on version 3 of this. And as we're going forward and making the information easier and more accessible for the public, we're also thinking about how we can reach other populations as well. And so one of the things that we did over the last year was we brought forward a Spanish edition of the fire and smoke map. Simple toggle, you can go right over and see all the information presented in the map in Spanish. Another alternative that we have now is to have a toggle that provides an alternate color scheme for colorblind individuals. That one is particularly near and dear to my heart because my son is one of those that has that kind of red-green color blindness. Now, I talked a minute ago about coverage for the fire and smoke map, and we have 1,000 permanent PM 2.5 monitors around the country. Right now, there's an additional 14,000 of these sensors that are appearing on the fire and smoke map. And we're comfortable as EPA and the Forest Service in saying that those particular sensors that we see on the map right now can be directly compared to the regulatory monitors that are showing there as well. So we've got tremendous additional coverage as a result of putting sensors onto this. Now, when we started this pilot, we were working closely with one company, Purple Air, and we're now evaluating a couple of other manufacturers of sensors to put those on the map as well, to broaden that coverage as well. And hopefully we'll see that happen in this coming summer before next fire season, presuming that they can go ahead and reach that apples to apples comparison that I was referring to. And then the next slide is just my contact information. Please feel free to reach out to me if you have any questions about the fire and smoke map or anything else associated with sensors and EPA.
Super. Well, thank you very much, Ron. And so we've gone from kind of space-based in the NASA presentation to the whole mix from space to airborne to ground-based sensing at NOAA to EPA's activities that are ground-based. And this is really a good segue to our next two speakers, as Ron talked about communities. We're going to hear more about more community-focused activities outside of the federal government sector. And also, I just want to highlight that wildfire smoke has become such a hot issue of late. And we're seeing, in addition to what Ron described with EPA and Forest Service, a lot of Department of Interior activity and a lot of NASA and NOAA engagement as well. It's partly just such a dramatic issue. It really gets people's attention, and we know that fires are getting worse. But saying that, let me stop screen sharing, and I am now going to hand the baton to Dr. Colleen Rosales. She is the Strategic Partnerships Director at OpenAQ, which is a nonprofit aiming to fight air inequality through open data. And Colleen, yes, please take it away. Thanks.
Thank you, Steve. Thanks for that introduction. And thank you for the opportunity to share today about OpenAQ. And it's a very opportune time for us because we just launched a revamp of our website just this week. And so if you head on over to openaq.org, you'll see a lightweight website as compared to what it was before. And also we have a new Explorer tool, which I will talk about in a little bit. So as Steve mentioned, we are a nonprofit aiming to fight air inequality through open data. And so by providing universal access to air quality data, we aim to empower a global community of change makers. All right, so as I mentioned, we are a platform, we are a website, and we are also a nonprofit, and we harmonize air quality data from disparate sources all over the world. So in the US, that includes AirNow, as Ron has mentioned a while ago. And so all of these publicly available data sources are aggregated and harmonized within OpenAQ. And we put that out in a format that is standardized and able to be used publicly and freely by a multitude of users for any use case that they have. So as I mentioned a while ago, our website has just undergone a revamp. So if you head on over to openaq.org, you'll see a newer look and feel. If you're already familiar with openaq.org, you may notice a drastic change in the look and feel of the website. But in addition to that, we also have the Explorer tool, which you will be able to access in explore.openaq.org. So here is a small screenshot of the Explorer tool that we have right now. In the platform, we have about 25 plus billion data points in 48,000 locations all over the world. The pollutants that we have on the platform are outlined here, mostly on air pollution or related to air pollution, but there are some also that are related to climate change. What I haven't listed here, we also have methane and other sizes of PM as well, albeit those are more sparsely distributed. And so the sources that we gather from are both reference monitors as well as air sensors, is what Ron has mentioned a while ago. So initially, OpenAQ was built to gather reference monitors, reference monitor data. But with the rise in the use of air sensors and enabling communities to measure their own air quality locally, we find that we can also gather these data from air sensors. And in fact, 80% of the data right now at OpenAQ is mostly air sensor data, and that has also allowed us to have more points all over the world. And so in terms of data products, what we have are programmatic access via the API. And then we also have a bulk or historical download via the archive. And then right now, we have the revamped Explorer tool that you can access via the website. So different tools for different types of uses. Also, we have just released in December our Open Air Quality Data Global Landscape Assessment, in which we find that 61% of the countries and territories all over the world monitor air quality data. So some of them do make it, or well, majority of those, 61%, share their air quality data. Some of them don't, and the rest do not monitor air quality data by the government. And so we find ourselves also not only promoting publicly accessible air quality data, but also promoting air quality monitoring data per se. And so you can access that report. Again, it's open and free to access using this short link or the QR code. And then, so going back to the platform, who makes use of the data in OpenAQ? So in the past, primarily it has been researchers, air quality scientists, as well as more technical users. And now with the release of our Explorer tool, we hope to be able to have a more diverse audience that can use the data in OpenAQ. So it's not just those that can access it via the API, but also those that can just go to openaq.org and then view the plots from there and generate their own plots from there. And so these are just some examples of use cases at OpenAQ or that use data from OpenAQ. So one example is a chatbot based in India. And so you're able to, text this chatbot via WhatsApp or Facebook Messenger and ask, what's the weather, what's the air pollution out there today? Like how you would, ask, for example, Alexa or Siri, what's the weather outside? And then it will also, communicate some sort of how do you, avoid this air pollution outside. We're also used by the Bloomberg Green PM2.5 tracker, which combines air pollution data with population density all over the world. And then some other initiatives that we support or also make use of the data in OpenAQ is Clean Air One Atmosphere, which is based out of Ghana, but they've also put out low-cost sensors in the Gambia. And then there's also AQAI, which is a UNICEF-backed startup aiming to use machine learning models to kind of extrapolate data in areas where there's little to no air quality monitoring. And so those are just some of the use cases. I invite you to play around in the new OpenAQ website and, type your zip code or type your current location in there. And then see what the current air quality is in your area and see if there are monitors around you or no. And if not, that might spark some action. And so we're also available this whole week. We have a session on the 26th that is more on the use cases of OpenAQ. And if you want to learn more about the API or the platform, and then we also have a research poster that focuses more on the report. That's it. Thank you.
Thank you very much, Colleen. And outstanding time management also. You came in at just about exactly 7 minutes. Thank you. Thank you for that. So as our final speaker and panelist, I should say it's kind of a combo. We're going to start with Karen Moe. And Karen is a retired NASA employee and a charter ESIP member. I think she was there at the very beginning of ESIP. She's managing, so we've talked about community-based approaches. She's managing the hyperlocal air quality monitoring network in her small town of Cheverly, Maryland, a Washington, D.C. suburb. And they've implemented a fairly dense network of purple air sensors. They've also received, well, I'll let her describe. So in addition to Karen, I'll let Karen introduce Chen, who is also a last year ESIP fellow who helped to support Karen's work last year. But Karen, please take it away. And I see your screen. If you can get it into slideshow mode, that would be great. In this format, there's towards the upper right, there's that little thing that says slideshow next to the yellow share. Go to the upper right.
Right, I'm trying to pull that portion up.
You see that the yellow share icon, upper right of the screen?
Yeah, let me, right now, it's hidden.
Oh,
I'm sorry, I have to stop sharing.
I struggled with this a little bit myself.
Right. Okay, I'm going to try again. And
It's partly, yeah, there you go.
there we go. And hopefully it
Yeah,
pulls the screen properly.
it's a bit slow, but I think we're good. Yep.
All right. So, yeah, let me just say thank you. What I wanted to do today is quickly talk about how we wanted to use the work that we've done in Cheverly as kind of a test bed for air quality cluster toolkit idea that we've talked about in the in the air quality cluster. And so using a little information that came from a workshop on value propositions on Monday, Steve and I were both in that session. And I think that what I'm hoping that we can do is provide a platform in which this project can serve as this test bed for evaluating the toolkit components that we might come up with. We can evaluate them with a real life community and get their feedback and start generating some components that can be used. The reason that I think this community is useful is that I think it's very typical of many communities in the United States near a metropolitan area, surrounded by a number of industrial sites and proposed industrial sites, as well as a lot of heavy traffic with trucks and diesel products. So we've implemented a large number, 22 units of sensors of purple air within about a 1.5 mile square mile township. So we did get approval for an air quality monitoring dashboard, and my value proposition that I practiced on Monday is that the Cheverly air quality monitoring dashboard can help the town of Cheverly, our managers and volunteers. We want to focus on some specific audience for the tool who want to protect their health and environment from air pollution by helping them access and use actionable air quality and health information, and use that so that they can influence county decision makers who are evaluating proposed local industrial developments. Now, there are other community uses of air quality data, but I'm kind of focusing on that one. So at this point, I'd like to turn it over to Chien to give a quick demonstration then of the system. And I'll just say that in my package, I won't really go over it, but I have some sample questions from my community from 2 different sessions that I held with them. They're a community advisory board. So kind of in response to one of Monica's comments of getting feedback directly from the community. So let me stop sharing and turn it over to Chien. She developed this website based on winning a proposal from the Funding Friday last summer. Chien?
Thank you, Karen. So I just put our public available dashboard link to the chat, and it's titled Cheverly Community Air Quality Dashboard. So as Karen mentioned before, this dashboard aims to provide some information and resources on air quality and mitigate community concerns regarding their public health impact of local air pollution during industrial activities and diesel truck traffic, and help prepare the community around the exposure risk. So, and we also list our contact information here for questions and for the suggestions. We got some idea from Steve's air quality in Los Angeles story map and decided to put 12 tabs for now, covering the website and maps about air quality monitoring, forecast, health impact in the town of Cheverly and the surrounding areas. So here's the introduction page. So we have a brief introduction and air quality guide publication. So this one provides some information about particle pollution and ozone pollution, like good is 0, like air quality index, good 0 to 50, moderate 51 to 100, and unhealthy, very unhealthy and hazardous. So it provided some brief introduction of AQI. And then we also have a Google map to show the study area. We categorized the website and maps into 5 big categories. And under each category, the category 1 is air quality monitoring. And under each category, we have subtitles for detailed information and the website links. And some maps are highlighted and put into a separate tab on the dashboard. For example, Purple Air, we have here, there's a real-time air quality map from Purple Air. And when you click sensor, you can see the EPA PM 2.5 AQI, and most of the areas have moderate AQI right now in Cheverly. And then we, for other, we also have AirNow Maryland aware, and the second big category is air quality forecast. We listed Maryland Department of Environment air quality forecast and NOAA air quality forecast guide, and AirNow ozone and PM AQI forecast. So for example, AirNow forecast, when you come here, you can click forecast and it will bring you direct you to Cheverly community area. And then when you click today and tomorrow, you will see different forecast for PM 2.5 AQI. All of those are real time. And then we also have weather tab for National Weather Service Forecast Office, Weather Service Radar, and a wind map, and real-time satellite imagery. And the 4th category we have here is demographic data and county zoning atlas. So we provide some demographic information for the communities. And we also have County Atlas user login. You can get some more information from there. And the last big tab, big category is air quality and health. We listed Prince George County air quality and health, and it will give you some guidance of what you could do during monitoring moderate or very hazardous areas about air quality. And then we also have air pollution data portal. It listed some data about how air quality can impact human health. And so we will have our more detailed information on our showcase tonight. So feel free to explore more, and that's it.
All right. Well, thank you, Karen and Chien, and we should also congratulate Chien on her pretty recently received PhD. So
you.
congratulations for that. And I also noticed in chat that a young son received a nice award from NOAA. So that was discussed in the chat I saw. All right. Well, thank you very much to all of the speakers. And now we'd like to shift gears a little bit to a bit of actual panel discussion. So if you're willing and able, speakers, to turn on your cameras and unmute, please do so. It is optional, but and what I'm going to do is try to open with several questions and then invite questions from our general participants. But I thought I would open it. It was something that Monica Unseld was asking about. I saw Monica had to leave us, but this is for the federal agencies. Could you just talk briefly about what you're doing to get input from actual communities in the sense of the Cheverly, Maryland type communities of the world, small communities that may be vulnerable, disadvantaged communities. So if any of you would like to speak to that, please, Ron, maybe you might have some thoughts on this.
Sure. There's a variety of things being done at EPA. I think the biggest thing is the community grants that I thought spoke of earlier, where part of the grant requirements was that a community group had to be the lead for these grants. Now they may be partnering up with cities, they may be partnering up with state agencies, they may be tribal operations, but all of these grants were things that first and foremost were there to have community input, community leadership, to be able to determine what are the problems going on in their areas, what information would the communities like to be gathering. So that's probably the most recent and biggest one I could point to for EPA at the moment.
Great. Thanks, Ron. Young Sun, do you have any thoughts on this? Go ahead.
Yes, so for National Weather Service, current services for the entire US and then US territory, but also the National Weather Service is making a lot of effort to provide the service that is equity service, the community equity service. So that is not the universal to the community. Some vulnerable community can get information more easily. So we are working on that social equity part right now, and then there is a team to working on it, so it can be improved.
Thank you. David, anything more? This kind of builds on what you were describing about what Maya is trying to do, but if you'd like to say anything.
Yeah, I really can't speak on behalf of the Maya mission. That would probably be, as far as what the mission can do, that would probably be a question for the mission PI, which is Dave Diner at JPL. So if anybody has a specific question to ask, I could relay that over email. But on the work that I'm particularly focusing on is more early adopters engagement. So really trying to set up workshops, ideally on an annual basis, to have early adopters, and this includes the Maya science team that's already funded as funded investigators for the NASA Maya science team, but it also includes self-funded communities and groups that are just curious about what Maya will have to offer the knowledge that's extracted from the data. So some of these could be non-technical people as well. But yeah, so part of why I'm here is really just to see if this is if anybody with an ESIP could be a possible provide a possible entry point into additional early adopters that we could bring into the conversation.
Great, and this is a community, yeah, where you're likely to get some input for sure. I would also mention I've kind of peripherally seen NASA's Health and Air Quality program, the so-called HACAS program, and my sense is that HACAS has been trying really hard to interact with outside communities, including kind of the EJ world, and get their input, which is great. Well, I understand we have some questions that have come up in Slido, so maybe we can turn to those for a second. If you can maybe feed us questions, please. And you may be muted.
Steve, I'm sorry, who did you have watching that Slido for you?
Actually, C Yang, I guess, was looking at Slido, and
yeah, Steve, there are 5 questions over there. So let's see, the earliest question was asked to Karen. Could you, no, the earliest one is, what is the spatial resolution and temporal resolution for Maya's primary target area? That's a question for Dave.
yeah.
Yes, let me look that information up real quick. I believe it's 1 kilometer, but let me just quickly locate that. I have that.
Yeah, David, there's also a question asking you if you could share your slides.
Yes, that is my intention. I'm waiting for the approval to do that.
Yeah, we plan, he has to get the approval, but we plan to add his. We've uploaded the other slides. And yeah, I forget about Slido. That Slido is out there as well. Thanks, Susan. So yeah. I don't know, maybe one of our Phil, thank you for pointing that out. Maybe rather than rely on you, maybe one of our ESIP folks could feed more questions that they're seeing in Slido, if you be so.
Yeah, there are 2 questions for Young Song. The first one is, are your quality data and models in the cloud? If yes, which region?
So NAQFC data is currently archived in the NCI. I forgot the acronym. So NCIE, National
Center for Environmental Information, right? Isn't that?
Yes, correct. Yes.
The
data is archived on the NCIE, so public can get the data from it. And then I heard that Nestis is moving all the archive to the cloud. Eventually, it may take years, but they are moving data to cloud, and then air quality data is also moving along with other data. But currently, all the archives are accessible from NCIE website.
Yeah, another question for Young-sung is that do you have the accuracy information or uncertainty information about the forecasting data, especially PM 2.5 and ozone?
We evaluate forecast against AirNow observations. So we have that kind of statistics, but we do not have currently uncertainty information available. And then what is the other one? Accuracy? Accuracy is against, accuracy is against the AirNow observations.
Yeah, thank you. There's a last question, which is for Karen. I guess it's also for everyone on the panel. Is that Karen, could you elaborate more on the community demands or questions? And how do you vision that can be addressed collaboratively by the ESIP community? For example, using the EPA sensors and using the OpenAQ data sets.
I really foresee trying to provide some analysis tools to answer some of those questions. The one that I'm pursuing started out looking at an air quality baseline to try to show the changes and trends in air quality over a period of time. And so I know with ESIP meetings in the past, we've tried to look at what is a baseline, how far back can you go? And so we now have about 2 years of data from our Purple Air Network, but really kind of want to see what was our air quality, say 20 years ago, and then show the progression as more and more land is taken up for warehousing, where trees are removed for new businesses setting up warehouses and the facilities like that. So trying to get air quality information, at the level of basically a MODIS pixel, and then being able to compare the ground data that we've associated with, say, some of the longer range timeframe data that you might have from satellites or other sources like as being accumulated by OpenAirQ. So I'm hoping we can see if there's some ways of coming up with analysis tools to provide that information together so that you can kind of see those trends.
Mm-hmm. Great. Thanks, Karen. And Phil, thank you for reminding us about Slido and feeding the questions. I'm going to toss one to the entire group. It's sort of two-part, so I'll give you both parts. I'll let you wrestle with it a little bit. But I'm interested in thoughts from the group about what are the big opportunities that you see coming up, and also what are the big challenges that you see, with our current situation. So I'm thinking primarily technologically here, but also maybe partly methodologies as well. For example, if you think of participatory science as kind of a broad methodology. So challenges and opportunities, if anyone wants to bite at that one and kick it off.
Well, I think in terms of the challenges, technology development, PM 2.5 sensors are getting to be pretty much state of the art. They're giving good information when you apply the right correction equations. They're pretty damn good. From there on, as you move into ones that are looking at NOx, ones that are looking at toxics, they need more work, is the best way to describe it. I'm hopeful, based on what we've seen from PM 2.5, that 5 years ago there were random number generators out there being offered to where we are now. So I foresee that technology is going to be improved in all these areas. It's just more challenging, and the idea there is that we have to make sure that the public recognizes that a lot of these technologies are still coming, and that they are not ready for prime time use the way the PM 2.5 sensors are right now.
Excellent. Yeah, I do have a personal fantasy about, and this exceeds my technological understanding, but I've seen recently that some spectrometer type technologies are being reduced down to chip scale. So I do have this fantasy of inexpensive, high quality, whichever exact technology of mass spectrometer becoming widely available. And of course, 30 years ago, we wouldn't have thought we'd have all this stuff that we have now on our smartphones, most likely, widely available and semi-affordable. So anyway, that's just a personal fantasy that maybe we'll see that maybe within my remaining lifetime. I don't know. Any other thoughts from any of our other panelists? Challenges and opportunities? Young-sun.
Yes, for air quality modeling, one of the biggest challenges is computing resources. So yeah, so the weather community is moving toward probabilistic forecast, and then it requires ensemble model runs. And then air quality model currently not have enough computing resources. And then I'm not sure how many years it will take for us to be able to run ensemble. But when we are able to run ensemble forecast, then we can provide a probabilistic forecast and also uncertainty information to the public. So that is one of the biggest challenge for us.
Good. Anyone else want to tackle this one?
Well, Steve, I would add, there was a discussion yesterday, and it's really has to do with combining the air quality information with other kinds of information, especially if you want to use that information to inform and influence people. And in particular, you get tied up with the health information. I thought in David's presentation about a comprehensive look at really the impact of air quality on health. And so if you're trying to make measurements to help in the decision-making process, bringing in the appropriate kind of health statistics, I think, is really important. And then the other factor that showed up in a meeting, a session I was in yesterday, had to do with the legal aspect. And we're certainly facing that with zoning laws that are, controlled by county levels, and priorities that overlook health priorities when they're making some of those decisions. So it's a matter of being able to combine a lot of information to make that data really actionable.
Yeah, I will editorialize it. You're reminding me. I think a big challenge is, the actionability theme, to communicate to people, truly actionable things that they can do to protect themselves, that their property, their pets, their gardens, whatever. What can you actually do? And I've used this before, but one example that I heard in the wildfire context from someone in EPA's Office of Research and Development, they made the point that in one of these horrific, ultra high PM smoke plume situations where people are evacuating because the smoke is so toxic, they made the point that people should be instructed to, assuming they have a relatively later model car, run the AC on recirculate, because that cabin air filter will do something for you, at least. If you do that, that seems so simple and obvious, when I heard it, but I don't know that people would automatically just know that they might want to do that in this kind of situation. So I just use that as an example of, what's genuinely actionable information. And I would point to, this is an area where I think National Weather Service, I am kind of a weather geek, and I've seen that National Weather Service has developed more clarity about the call to action concept when it issues a warning, that it seeks to tell people, what should you do? Or what should you not do in some cases, like turn around, don't drown, right? So I think there's a lot of opportunity there, and it's sort of in the title of this session, but there's opportunities to truly save lives, and protect people's health. The better jobs we can do, in addition to providing the basic information, the data, good guidance to people about what they can do. I mean, another thing is just don't go out and do vigorous exercise during a high ozone event, for example, especially if you're otherwise sensitive. And if you feel like you have to exercise, maybe understand that ozone levels tend to build up during the day. And so you might be better off doing your run early in the morning before you go to work, rather than late in the afternoon after you finish your normal work. So
Steve, if I could, just a couple of points. One, you're thinking about what you're saying about smoke. The Western states in particular are really, over the last year and a half, putting a lot of information together, telling people what to do in the event of smoke. And there's been a lot of testing going on how to put filters on box fans to improve the air quality in their houses and such. And the other point I wanted to make, and I see Colleen up in my upper right here, there is a tremendous amount of data being collected individually. And how do we bring that data together is a real important factor. And my poster child for this is that last May, I was at a conference, and it was clear to me after listening to some of the presentations, there are 5 sensor networks going on in the LA area, and nobody's pulled them together. That to me is a low-hanging fruit, if you will, of figuring out ways to share that data.
Yeah, we are also aware of this even in the community level. So we know of at least one network or one, community-based organization that was going to put up their low-cost sensor. And then they come to the location, and apparently some other community-based organization has already put up a sensor in there, and they've already spent the time and whatnot. And so we do want to be that, one-stop shop in looking at all sorts of air quality monitors and sensors in a certain area. And we also find ourselves to be not just scraping the publicly accessible data, but being also someone to convince entities to open up their data. And the other challenge that we see is that for example, other governments see the benefit, but are have the fear of not opening up their data for fear of being punished because their air was bad or something like that. And so even if we know that there are 9 good reasons but 1 bad reason why they wouldn't open up their data, they latch on the bad reason. And so we find ourselves to be just continuously convincing in terms of it's good to open up your data and whatnot. And then going back a little to the technological development aspect, one opportunity that I see as well, and a lot of people I know are doing, are calibrations, like general calibrations, and as well as local calibrations or corrections for sensors and monitors, such that it's applicable to the certain locations. And we know that in some areas the sensors are good right out of the box, but in some areas it's not necessarily it needs more corrections or something like that. And so I see that as an opportunity, especially in areas where there is no reference monitor. And for example, these sorts of collaborations can happen between entities with the reference monitor who'll bring their reference monitor there for a little while, correct it with the low cost monitor or low cost sensor that would, stay there forever. And then, yeah, have that correction factor for that.
All right. Well, I'm going to toss one more question at everyone, and then I should explain again. We're going to make a transition after this. We'll close out our official panel segment. And again, I really appreciate all of you for speaking and contributing. We'll do a very short break, and then we will open up breakout rooms. And what we're going to try to do is to use smaller group discussions to basically, I will ask each group to self-organize a little bit, and maybe we'll get some help, but self-organize a bit, but look at the Google document, the shared document, and toss onto that document. It can be rough, but what resources, should we be tracking? Information resources that we don't already have, or you're not sure that we have it, it doesn't matter. And also, are there community questions that we haven't captured that we should capture? So let me just ask this last question though, before we close out the panel. Have we missed anything that any of you think is really important that we haven't at least touched upon briefly so far? Does anything come to mind as, well, we didn't talk about X? Open-ended question.
Yeah, may I have
Yes.
add something? Yes, one of the things we pay a lot of attention now is how we deliver the information to the public who needs. And then we provide a lot of information through website, but it requires people to visit the website and get the information. But there are generations who does not go to the website and get the information. So then how we deliver the information to people who does not, have access to those information, the regular tool we use. So that kind of information is very important, I think, and then that would be the opportunity for us to reach out to people who does not have.
Yeah, that's an outstanding point, Young Sun, and we didn't talk about that. And I certainly agree with you. And we have people who they go to their phone and they're apps oriented, or I know the federal government can't generate TikTok videos, at least not right now, but we have a lot of people where TikTok is a major information source for them, for better or worse. And how do you reach that kind of audience that's probably not going to visit the website? So really, really good point. Any other thoughts? Just kind of closing thoughts, folks?
Well, I'd like to just jump in and emphasize something that Karen pointed out in terms of analysis tools. Analysis tools for the public at large is something that's lacking. I've been in conversations where people say, well, there's plenty of different R-based tools out there that everybody can use. And you go ahead and if you mention that to the public, R-based? What is R-based? And so, there's just a need for community-friendly analysis tools, I think is the way I'd characterize it.
Great. Yeah.
Because what we found and Jen had put into that website were really just output information. A lot of it real time, some of it static and background information. But the analysis tools, how do you answer the questions? That's.
Yeah. And we certainly see a lot of people in the general ESIP community working with Jupyter notebooks, for example, and trying to kind of pull together something where if you're at least a little bit technically savvy, maybe you can take a Jupyter notebook and start to do some stuff with that. But for sure. Colleen and David, any parting shots? I see your cat, Colleen.
Yeah, so in terms of the tools, we hope that the Explorer tool would be one easier step in terms of trying to visualize the data. And so with the map, you see real time at this point in time, and then you click at one point, you'll see the time series for it can be a long-term time series or a 24-hour time series, depending on data availability. But we do hope that this would be one step easier rather than, having to access the API or download the CSV, although those are still possible. But at least right then and there, you can visualize, oh, this is the data for now for this location. And then we are also going to have trainings and workshops based on, how do you use this Explorer tool? How do you interpret air quality data with these charts and whatnot?
Great. David, yeah.
Yeah, so I will start off by admitting I'm very new to air quality science and air quality research, and that's not really what I did before joining partnering with Maya and the Early Adopters Program. So, but with what I have learned, what I've observed is that, and this is partially from the Early Adopters Workshop that I helped Abby organize a couple of years ago, was that, and one of the things that I had done was put together a Jupyter notebook to kind of do a walkthrough of some sample level 2 files and do some plotting. And anecdotally, what I've observed is that it's really helpful for people who are already familiar with Jupyter notebooks, who are already acquainted with Python code and things like that. But it's a bit of, there's an intimidation factor for the non-computer scientists and even the non-scientists in general that really just care about the plot itself, or they might just care about the knowledge that comes from the plot of the data. And one of the things that's really unique about Maya that I have not encountered on any other mission is that there's a significant user group that is not your traditional user group, that really is non-technical. And I've never encountered that before. And so it made me think we need to think a little bit outside the box. Maybe Jupyter Notebooks is not the answer for that user group. Maybe it's something else. And perhaps even Panoply is not even the answer. But one of the things that's also interesting about Maya is that it will be going directly to Amazon S3 and the NASA Earth Data Cloud environment. That is one of the cool things about that mission, is that will be the targeted environment. But then again, what does that mean for this group of users who is non-technical, who doesn't know anything about S3 or accessing data from APIs? There's going to be a whole host of really cool capabilities for subsetting and analysis with that targeted distribution environment. But I think we need to really think about how do we reduce that intimidation factor for that target user community?
Yeah, excellent points, everyone. And this is reminding me that there was a presentation yesterday, and I'm blanking on her name, but her company is Navteca. Her company is building or working with gamification, gaming, visualization type tools to provide user interfaces that are, maybe friendlier for an audience that isn't traditionally technical, but is used to playing games or whatever. And she was showing some very interesting stuff. So that's another kind of angle that's out there to kind of leverage virtual reality, AR, gaming, dare I say, metaverse type technologies. Well, let me mention Bob Chen has posed an interesting question. And what I'd like to suggest is I would encourage our breakout groups to maybe wrestle a little bit with Bob's question in chat during our breakout groups. That's a pretty thought-provoking topic that he's raising. But I do want to, oh yeah, Shayna Skolnick with Navteca, which is Navteca, right? Thanks, Douglas. Let's say I'm seeing 3:12 Eastern right now. Let's do a short break to 20 minutes after the hour. So roughly 8 minutes from now. And then I'll ask that Morgan fire up breakout groups for us, please. And what do you think? I think 4 groups, either 3 or 4. Let's say 4 breakout groups, given our participant count. Panelists, if you're able to hang in and join a breakout group, that would be great. If you have to go, I can understand, and thank you. But so please, if you need to, take a short break. We'll leave this room open for now. I know I'm going to run off briefly, and then we'll aim at 3:20, entering our breakout groups. And again, we're going to try to explore, capture resources on the Google Doc. So thanks, and see you in a few minutes. All right. Well, it is 20 minutes after the hour. So I'm hoping that folks have been able to rejoin. And once again, we're now going to shift gears a little bit and do breakout rooms. And these are going to be fairly freewheeling breakout rooms. In other words, we're not asking you, we're not giving you a set agenda. And partly because I'm a troglodyte technologically, we're not using some technology that could have helped us. Instead, we're going to try to point people towards the main Google Doc for capturing information. But what we're really looking for is, again, thinking about communities. What information resources should we harvest that could be useful to communities, especially vulnerable, disadvantaged communities? So I would encourage people to take a look at what's already kind of captured on that document if you browse through the document. But then, well, wait, they don't have this resource that's a really important resource, capture that kind of thing. Right now, it's not populated at all with articles, either journal articles or worthwhile reports, possibly noteworthy news articles. So that's an area that's a blank slate right now that I'd like to see populated. But we're really going to spend 25 minutes trying to go through this sort of freewheeling, capturing information, and then we'll reconvene for a brief closeout period, with some general open closeout discussion. So with that, we're going to do 3 randomly assigned breakout groups. And Patty, do you want to go ahead and launch those, please? So you'll find yourself assigned to a room, and you'll need to please join the room. And it will be possible, if you discover that for some reason you're not happy with the room you're in, you can go back to the main room and join a different room. Patty will be monitoring that. So Patty, take it away, please.
I'm assigning people now. So if you look down at the bottom, you should see a button that comes up. So I'm just kind of distributing people evenly.
Thanks, Patty. So hi, everyone, and welcome back to the main room. Thank you very much for breaking out, and I hope those sessions were productive. I do want to hopefully give people a few minutes of time back rather than run all the way to the exact hour. But let me just ask, open general mic, did anyone hear anything or think of anything that was especially compelling that you'd like to share with the entire group? You know, any flashes of insight, you know, or wow, yeah, this is something we didn't talk about that. Does anything leap to mind? Feel free to unmute yourself, go on camera and chime in if so. Don't be shy. Well, I'm just going to say, so Bob Chen talked about, I'm not going to capture this very well, but the importance of socio-demographic data, and that sort of led me to the idea of if I'm in community A, can I identify other communities that are similar to my community in terms of, you know, demographic characteristics, that, you know, sort of sibling communities, and are some of them more advanced than I am with air quality programs, where I might reach out to them and contact them and hopefully learn some things from them that I could apply in my own community. So we're kind of looking at Karen's community of Cheverly as our prototype, really, community for this air quality toolkit idea. So that was something we talked about in our group. Any other thoughts? And hopefully I was not looking at the shared document itself, but hopefully we captured some great stuff in the shared document. And thank you for that.
I know in our group, we talked a bit about other sources like smog from volcanoes, which is a problem in Hawaii. And then, you know, there's what about measuring things like pollens and you know, other sources of irritants in terms of that health aspect of air quality.
Yeah, good. Right. I think it would be fallacious to say it has to be anthropogenic to be of concern. You know, it really, my own view is we should be looking at everything, you know, even if it's of natural origin, and certainly vegetation, you know, could have impacts, both positive and detrimental.
So at the risk of sounding silly, I proposed a wearable air quality sensor, just like an Apple Watch, that people can wear and figure out where they are. You know, you want a real time, real place.
Yeah.
That's a good way to do that if one can be made for an affordable price. And those things can be linked and sent to the modeling, air quality modeling database. That would be neat.
I can show you, this is a Plume Air Labs Flow, and it's supposed to hook on your backpack.
I see.
And so not quite wearable, but it does measure NOx, or at least NO2, as well as the PM. And there might be black carbon measures as well. I mean, it was kind of designed for, or actually thoughts of using it for evaluating, you know, kids who walk to school and, you know, what issues they might have and what exposure they might have.
And how is the data from that gathered and saved and conveyed?
So it is gathered in your cell phone, and it's very private because it's basically
Mhm.
tracking where you are.
Right.
And so in order for us to use it, we really have to set it up as a very conscious experiment and get all of the participants to feed their data, into, or share their data.
But it can be shared with the source being anonymous. At this location, there was this kind of pollution. Right? It
Right,
doesn't have to
but-
be so-and-so was there. It doesn't have to be known.
Yep, but that would take some transition of the data.
Okay.
But yeah, I think Rama, I made the point earlier, 30 years ago, we probably wouldn't have conceived of what we can do with our phones today, in so many other realms. And so I don't think it's crazy to think about the sensing technologies that we could anticipate, within the not too distant future. And I would love the chip-based spectrometer, inexpensive, that's able to, actually do what the big expensive stuff does right now. I mean, even if we think about the first GPS receivers, right? When GPS started and GPS receivers were roughly suitcase sized and many thousands of dollars. And now pretty much every little device has a GPS chip. So, and we're seeing it with molecular, with genome technologies, we're seeing kind of Moore's law type stuff going on. So, well, listen, folks, I'm looking at the time and we're just about at the hour. So for those who are still here, thank you very much for coming and participating. And I think we got some great input. It was fun to see everyone and hear from everyone. Thanks to all of the ESIP staff for your wonderful support. And Patty is reminding us about the research showcase starting up at 4:30 Eastern. So please tune into that. And I think we'll close out now. So once again, thank you.
Thank you.
And stay well.
And I might mention that Chan and I will be at the research
Good. Yeah.
forum talking about our website work.
Good reminder. Thanks, Karen. All right. Take care, everyone. Bye-bye.
Bye-bye.
Bye. Thank you.
Bye. Thank you very much.